Section 7.5 is solving. 7.6 we actually did part of already. 7.6 is all the natural log stuff. So I kind of threw that in with 7.4, stop whining, when we did all the property stuff. And then I'm going to throw the 7.6 natural log solving in with this one as well. So we'll kind of do it all together. We're going to spend today and tomorrow. We're not doing all the notes today. We're going to do part of them today. That's like one method. And then tomorrow we'll look at kind of the other method of solving. Okay? So we're doing both exponential and logs, as you guys love your logarithms. All right, so if two expressions are equal and they have the same base, then the exponents have to be equal. Right? Like if I have 5 to some power equals 5 to some power, what has to be true about the powers? They have to be the same, right? They have to be equal to each other. All right, this is called the one-to-one property. Do I care that you memorize that it's called the one-to-one property? No, I don't care. I didn't even know that. I do this stuff all the time. I know what it's called. All right, so the one-to-one property, though, that's what it's referring to. All right, so for in this case, since the bases are the same, then we can just forget the base entirely, set their exponents equal to each other. Because again, if the bases are the same and they're equal, then obviously the other part has to be equal. So what does x have to be to make them the same? So then you just go through, subtract x, subtract 1 on this side, and you get x equals 3. So some of these are pretty simple. Does that make sense? Somewhat? Well, I mean, think about it reasonably. 5 to some power equals 5 to some power. So if each side's the same, what has to be the same about the exponents? Like, they got to be the same in order for the whole thing to be equal. Like if I said this was 5 squared, and I said that, 5 squared equals 5 to what power? 2, right? The x would have to be 2. In order for them to be the same, the exponents have to be the same. It's the same idea down here, except there's just more down here instead of just a 2. Okay? The exponents would have to be the same in order for the bases to be equal to each other like that. So what about something like this? 9 equals 3 to the x plus 1. I do not set the 9 equal to x plus 1. Are the bases the same? No. How can I rewrite the 9? Yeah. Now I'll have 3 squared equals 3 to the x plus 1. Now my bases are the same. 3 to what power equals 3 to what power? They have to be the same. Yeah. So since these are the same, that means these have to be the same. So 2 equals x plus 1. So x equals 1. And it makes sense. 3 squared equals 3 to what power? That means this would have to be squared. So that means it'd have to be 1 plus 1 gives it 2. You okay? Some of you are staring at me like I just said something very difficult. All right. 16 equals 2 to the x plus 2. Good. Thank you. You have to have the same base in order for this to work, guys. I need to make sure I stress that to you. You weren't wrong, but you know what I mean? Like, you have to have the same base in order to set the exponents equal. If they're not the same base, you can't do that. So now that the bases are the same, now that means my exponents must be the same. So x equals 2. Five to the 4x equals 25 to the x minus 3. Good. Yeah, change that 25 to 5 squared, and that the squared just multiplied by the x minus 3. Mm-hmm. Yeah, so since the bases are the same, now we can say these have to be the same. So 4x equals 2 times x minus 3. And then, yeah, we'll have to distribute and then solve from there. This is making sense? Base is the same. So we'll have 4x equals 2x minus 6. Go ahead and distribute. Subtract 2x. 2x equals negative 6. So x equals negative 3. All right, can I strain your brain a little on some of these? 1/2 to the x power equals 8. I need to rewrite so the bases are the same. What can I write the bases as, you think? I can write them as 2's. Hold on. I can rewrite both of those bases. This one's probably easier to see. 8 is 2 to the 3rd power. That one's easier to see. Right now, the 2's in the bottom. How do I move it back to the top? Has to have what type of exponent? Negative. So that'd be a negative 1x. Remember that negative exponent always flips them. So now the bases are the same. So that means the exponents are the same. So negative 1x equals 3. So x equals negative 3. Can you try these to make sure they work? Like, if you're like, wait, did I do that right? Grab your calculator. What's 1/2 to the negative 3 power? It's 8. The negative is going to flip the 2 up to the top, and then 2 to the 3rd is 8. So, I mean, you can always double check. Like, if you're like, I'm not sure I did that right, just plug it back in and see if it works. How about 1/3 to the x equals 81? What base can I rewrite them in? 3. What's this one going to be? 3 to the 4th. And then, how do I get 1/3 to just be a 3? A negative. Yeah, so negative 1 and then x. Yeah, remember that negative exponent's powerful. You can move things from top to bottom. So again, bases are now the same, which means those parts are the same. So x equals negative 4. It works. Holy smokes. Questions on that type of problem? Make sure the bases are the same, set them equal to each other. Yeah. I'm glad you asked. Oh, wait, there's more. All right, when the bases are not the same, ta-da, I can't rewrite them because sometimes I can't, right? You can't always make them have the same base. You can solve the equation by taking the logarithm of each side. It's kind of like, this is where your properties that we've been practicing, like the exponents that go out in front and all of that, that's where all of this comes into play. So for example, if I have 5 to the x equals 12, can I rewrite these so that they both have the same base? I can't. So that's the problem. Obviously, if I can, it makes these pretty easy. You just set the exponents equal and you solve. But since I can't rewrite them, then we have to take the log of both sides. Remember, if I do it to one side, I have to do it to the other side. So I went ahead and literally from this step to this step, all you do is write the word log on both of them. Okay? As long as you do it to both sides, you're good. Okay? Then we use our log properties. This exponent came out in front. That's what happened here. And then how do you get x by itself? How do you get rid of log of 5? You divide it. So if I divide both sides by the log of 5, that would cancel, and I get x equals, and you would literally grab your calculator and type in log of 12 divided by log of 5. Now be careful. Remember, after you type in log of 12, close parenthesis, divide log of 5. If you don't close the parenthesis, it's going to be wrong. So that was rounded to the 4th. I don't think I specified. All right. And I'm going to be honest with you, a lot of the solving we're going to do in this next part right here, a lot of it's calculator based. It's a matter of, can you hit the right buttons at the right time on your calculator? So Allie, don't freak out on me, okay? We're going to practice. All right. So 15 to the 3x equals 285. I can't rewrite that to the same base. So since I can't, we're going to take the log of both sides. So the log of 15 to the 3x equals log of 285. Right? First thing you want to do, if you can't do anything else, you take the log of both sides. It's got to be fair. If I do it to one, I got to do it to the other side. And then my properties are going to allow me to do what with my exponent? Move it to the front. So this exponent's going to come out in front. So 3x log of 15 equals log of 285. Now, here's where I'm really going to have you kind of go step by step, but I'm going to type everything pretty much in the calculator, okay? All right, so from here, everybody got your calculator? Because we're going to need this thing. All right, so first of all, we're trying to get the 3x part by itself, right? So we have to divide by log of 15. That will cancel out this log of 15 and give me just 3x equals, this is where your calculator is going to come into play. So let's type in log of 285, close parenthesis, grab your calculator, divided by log of 15. I'm not writing anything down at this point, okay? Because if I write something down, what am I have to do with it? I'd have to round it, and I don't want to round it. So everybody got that number in your calculator? Because then how do you get x by itself? Divide by 3. So now type divide by 3. So you have to type that back in again. So you should get be 0.6958 if we take it to 4 decimal spots. Okay, so this is going to be a lot of kind of mental math, but I'm just typing stuff in my calculator. Like, I know some of you love that, right? I don't have to write anything down. Obviously, we got to write some of it down, but then I get to a point where I need all the digits in my calculator, so I have to kind of like do some math just straight inside of there. Does that make sense? Okay, so let's take a look at the next one. All right, so 5 to the 2x equals 130. Can I rewrite 130 with 5 as a base? No, I can't. So since I can't, I'm going to go ahead and take the log of both sides. So log of 5 to the 2x equals log of 30. Again, literally at that step, all I've done is just wrote down log in front of both parts. That's all I did. But my properties allow me to do what with my exponent? Yep, it comes out front. So I have 2x log of 5 equals log of 130. Now, as you get more comfortable with this, could you write that straight from the start? Sure. I mean, that's fine. I'm okay with that. If you want to go straight from here to here, I'm okay with that. All right, I want to get this 2x part by itself, so I have to do divide by log of 5. That cancels it out here, gives me 2x equals, yeah. So guys, I want to make sure we're very careful though when we're typing stuff in. You're going to want to do log of 130, close parenthesis, divided by the log of 5. Hit equals, make sure you hit equals, get that number, then you're going to have to divide that by 2. Does that make sense? So you should get, oops, x equals 1.5122. Uh-oh, what happened? Didn't get that? Oh, I didn't even hear her. That's funny. All right. Anybody struggling at this point? Marcus, are you okay? Did you try typing it in? You're okay? Okay. Okay. So 6 to the x plus 10 equals 47. What do you think you should probably do first? Move the 10 over. Yeah. You want to get that part with the exponent by itself first. Yeah, let's subtract that 10 over. Then it looks like the other ones that we've been working on. So 6 to the x equals 37. Now it looks in that same form. You want to get rid of that kind of extra stuff. Can I rewrite 37 with 6 as a base? No. So So since I can't, remember we take log of both sides. Log of 6x equals, log of 37. That property tells me I can move my exponent out in front. X log of 6 equals log of 37. How do you get x by itself? Divide by log of 6. And look, there's nothing else with x, so that one's not so bad. So we should get 2.0153. Double check, make sure you're okay. How's today's lesson going so far? It's okay? All right. Yes, you can. Go ahead and try this next one on your own. All right. If you're not done, that's okay. Keep going. But let me go ahead and kind of break down at least the first part. We should be able to do okay. All right, so we take the log of both sides because I can't rewrite them with the same base. So 2 to 3 minus x equals log 565. So my properties allow me to move my exponent out in front. So 3 minus x log of 2 equals log of 565. To get this part by itself, we divide by the log of 2. So we get 3 minus x equals stuff, right? This is where the calculator, we're going to do it all inside of there. So we did log of 565, close parenthesis, divided by log of 2, hit equals. How do you undo this? If you're solving, what do you move? You'd subtract 3. So in your calculator, you should hit minus 3, hit equals. Then how do you get rid of a negative in front of here? You divide this by negative 1, because there's a negative 1 sitting there. That is correct. So x equals negative 6.1421. Did you see why I'm not writing all of this down step by step, that I have to use the calculator though? Because of all those decimals inside of there. If I start writing it down, I have to round it off, and I don't want to do that. Your calculator is holding on to digits that it's not showing you. Do you know what I mean? Like there's more digits, but the display screen just can't show them. But it's holding them. All right, so we're going to kind of skip and jump a little bit here. Let's jump all the way back to the last page of your notes. Because the other stuff's kind of switching gears, and I'll save that for tomorrow. We're going to go to solving a natural logarithmic equation. How do I know that natural log goes with this stuff? The e. Yeah, it's because there's an e in there. Do you guys remember when we talked about the first time I showed you the natural log button on your calculator? We talked about how it's the opposite of what's above it. And we're kind of like x squared and square root. They're on top of each other because they're opposites. They undo each other. So the same thing happens here. Natural log and e's, they're opposites. They undo each other. Okay? So on something like this, me taking the log of both sides is not real conducive. It doesn't help because of that e that's sitting there. Right? It doesn't help. So if you see an e, use natural log, ln. Okay, if you don't see an e, we use regular old logs. But with e, its opposite is the natural log. They undo each other. So my only guess, and I really don't know the answer for sure, but my guess is all of math comes from like Latin background, different language, which natural log to them probably log au naturel or something like that. You know what I mean? Like it's usually reverse of how we say it. That's probably why it came from there. All right, so instead of taking the log of both sides, since there's an e, I'm going to do the natural log of both sides. So it's just like the other part, where I'm going to do the same thing on both sides, natural log of both. Yeah, so I'm going to use my properties. I'm just going one step at a time for you. My property says I can take my exponent out in front. What's the natural log of e? It's 1. So do I need natural log of e? Well, I actually need it. It's 1. Now, if I forgot and divided by the natural log of e, does it make a difference? Does dividing by 1 change anything? It doesn't. Okay, so I just want to make sure you're clear, though, as far as natural log of e, that's just 1. And if you're unsure why, think about natural log is the same thing as log base e. So in essence, it's asking you e to what power equals e? E to the first. So that's why this whole piece just becomes a 1. And multiplying by 1 doesn't change anything, so I don't really need it. Okay, so natural log of e, cross it off. It's gone. So really, I have x minus 2 equals natural log of 12. So how do I solve this? Add 2. Yeah. So x equals, type in natural log of 12, close parenthesis, plus 2. .4849. So it's the same process as taking log of both sides. We're just doing natural log of both sides. I actually saved myself a little dividing step because I don't have to divide by natural log of e. That just cancels out. Could you divide by that? Sure. But you don't have to. All right, so let's take a look at the next one. What should you do with the next one first? Yeah, subtract that 2. Now what should I do? Nope. Is the e by itself? Divide by 4. Yeah, you're trying to take as much away from that as you possibly can. So e to the 2x equals, I'm just going to simplify my fraction to 7 over 2. It doesn't divide nice, so I'll just go ahead and simplify it. All right, so once your e is by itself, what's the opposite of e? ln, which is, what's that stand for? Natural log. So the natural log of e to the 2x equals the natural log of 7/2. Can I get rid of the natural log of e right here? Yep, I sure can. So 2x equals natural log of 7 over 2. Yeah, a natural log of e, that's just 1. So I have 2x equals natural log of 7 over 2. How do I get x by itself? Divide by 2. So what is the natural log of 7/2, close parenthesis, divided by 2? 0.6264. Good, good, good. All right. Last 2 problems. Does anybody know what his name is? Why don't you do the first one on your own? His name is Spike, in case you're wondering. All right, here we go, guys. What's the first thing you want to do in this problem? Good. Divide by 2. You want to try to get that part by itself. So e to the negative x equals 10. If you see an e, you know you have to do what? You have to do natural log. So natural log of e to the negative x equals natural log of 10. What do we know about natural log of e? It's going to cancel. I'm going to have negative x equals the natural log of 10. And then Then how do you get x by itself? Yep. So the natural log of 10, close parenthesis, divided by -1. Beautiful. Now, real quick, grab your calculator, because you can check all of these, but I don't want you to freak out if you try to check something. Okay? Grab your calculator, type in 2 times e to the negative 2.3026. Right, so it would make it a positive 2.3026. Wait, you got what? You'd either put it in two negatives or two negatives make positive. So 2.3026. So if you type that in to check it, do you get exactly 20? You typed it in wrong. Did you remember the 2? 2. You should have gotten close to 20. All right, like I got 20.000298814. What did you do? Oh, you flip-flop two numbers. It's 30, not 03. You transpose two your numbers. We're doing more solving. That's slightly different. All right, and then the last problem, what should I do first? Minus the 5. So e to the 3x equals 10. If you see an e, you know you have to use what? ln, natural log. So natural log of e to the 3x equals natural log of 10. If I do it to one side, I have to do it to the other. What do you know about natural log of e? It's going to cancel out. So 3x equals natural log of 10. And to get it. Good. That is perfect. 0.7675. All right, at least one of you's got this down. How about the rest of you? Two of you? Yeah, you got it? You got it? Good, good, good. Allie, you awake back there, sweetheart?